When you look up at the stars, what do you think about? That we may not be alone? The vastness of it all? There's a lot to wonder about space. The fact is, we don't know all the answers about it. We know it's vast and beautiful, but we're not really sure how vast, or how beautiful for that matter. Some of the things we do know, however, are downright mind-boggling. Here, we've collected some of the most amazing facts about space, so when you look up at the stars, you could be ever more wowed by what you're looking at. Neutron stars can spin at a rate of 600 rotations per second. Neutron stars are one of the possible evolutionary endpoints of high-mass stars. They're born in a core collapse supernova star explosion and subsequently rotate extremely rapidly as a consequence of their physics. Neutron stars can rotate up to 60 times per second after born. Under special circumstances, this rate can increase to more than 600 times per second. Space is almost completely silent. The misconception that there is no sound in space originates because most of space is a vacuum, providing no way for sound waves to travel. Sound waves need a medium to travel through. Since there is no atmosphere in the vacuum of space, the realm between stars will always be eerily silent. A galaxy cluster has so much gas that NASA has picked up actual sound. Here it is, amplified, and mixed with other data to hear a black hole. That said, worlds with atmospheres and air pressures do allow sound to travel, hence why there's plenty of noise on Earth, and likely other planets as well. There is an uncountable number of stars in the known universe. We basically have no idea how many stars there are in the universe. Right now, we use our estimate of how many stars there are in our own galaxy, the Milky Way. We then multiply that number by the best guesstimate of the number of galaxies in the universe. After all that math, NASA can only confidently say that there are zillions of uncountable stars. A zillion is any uncountable amount. An Australian National University study put their estimate at 70 sextillion. Put another way, that's 70,000 million. The Apollo astronauts' footprints on the moon will probably stay there for at least 100 million years. Since the moon doesn't have an atmosphere, there's no wind or water to erode or wash away the Apollo astronauts' mark on the moon. That means their footprints, rover prints, spaceship prints, and discarded materials will stay preserved on the moon for a very long time. They won't stay on there forever though. The moon is still a dynamic environment. It's actually being bombarded constantly with micrometeorites, which means that erosion is still happening on the moon, just very slowly. 99% of our solar system's mass is the sun. Our star, the sun, is so dense that it accounts for a whopping 99% of the mass of our entire solar system. That's what allows it to dominate all of the planets gravitationally. Technically, our sun is a G-type main sequence star, which means that every second, it fuses approximately 600 million tons of hydrogen to helium. It also converts about 4 million tons of matter to energy as a byproduct. When the sun dies, it will become a red giant and envelop the Earth and everything on it. But don't worry, that won't happen for another 5 billion years. The largest asteroid in our solar system is a mammoth piece of space rock named Ceres. The asteroid, which is sometimes known as a dwarf planet, is almost 600 miles in diameter. It's by far the largest in the asteroid belt between Mars and Jupiter and accounts for a whole third of the belt's mass. Ceres' surface area is approximately equal to the land area of India or Argentina. The uncrewed spacecraft Dawn finished up its mission orbiting Ceres in October 2018, helping us totally transform our understanding of the world. One day on Venus is longer than 1 year on Earth. Venus has an extremely slow axis rotation that takes about 243 Earth days to complete one full cycle. Funny enough, it takes Venus even less time in Earth days in order to complete one revolution around the sun, 226 to be exact. Furthermore, the sun rises every 117 Earth days, which means that the sun will rise only 2 times during each year, which is also all technically in the same day. Since Venus also rotates clockwise, the sun will rise in the west and set in the east. Jupiter's red spot is shrinking. Jupiter's famous red spot has been shrinking over the past few decades. This spot on the planet is a giant spinning storm that used to be able to fit about 3 Earths. Now, only one Earth can fit inside the spot. Interestingly enough, as the storm is shrinking in width, it's actually growing taller in length. Scientists are still stumped as to why this phenomenon is occurring in the first place, but some theorize that it may have to do with jet streams on Jupiter that have either changed direction or location. One of Saturn's moons has a distinct two-tone coloration. Iapetus, one of Saturn's 62 moons, is actually a pretty unique celestial object. This moon has a very distinct two-tone coloration, with one side much darker than the other. This strange occurrence isn't present on any other moons in the solar system. Iapetus's color has to do with its position in relation to the rest of Saturn's moons. It turns out that Iapetus is way outside of Saturn's rings, and because of this, it gets hit with a lot of space debris from objects that might be passing through its orbit, explaining the dark areas, according to Forbes. Furthermore, another moon, Phoebe, which is completely dark and farther out than Iapetus, revolves clockwise around Saturn and emits a steady stream of particles. Iapetus revolves counterclockwise, meaning that only one side of Iapetus gets hit with the particles coming off of Phoebe when they revolve past each other. This explains why Iapetus isn't fully dark, but only partially. The position of the North Star will change over time. Navigation will be weird when Polaris stops being the North Star in about 13,000 years. In case you didn't know, Earth's axis goes through a motion called precession, which means that the planet's axis will change and trace out the shape of a cone, even if slightly. When this occurs, it takes around 26,000 years for the axis to trace out a complete cone shape. To add to this, Polaris, the Earth's current North Star, will eventually begin to shift positions as the Earth undergoes precession. In 3000 BC, it's believed that the North Star was the star Thuban, otherwise known as Alpha Draconis. In about 13,000 years, the star Vega will be the new North Star, but in 26,000 years, Polaris will return in its original position as the Earth continues to go through precession.